Hello, my name is John Riles, and I'm going to be presenting today on the Ebola virus disease and the vaccine. As we can see from this picture, Ebola virus is a pretty big deal, and um, recently I made a comment during class that it's pretty scary, and I hope to show you, that Ebola is scary, and the vaccine has produced some good outcomes for those populations suffering from infection. So the Ebola virus disease. So it is a deadly disease. So the mortality rate from the disease is 20 to 90%, depending on the strain. So the Zaire Ebola virus strain, which is the one where the outbreaks have been the most severe, um, is the one that has the very high mortality rate of close to 90%. And from over here on the right, this graph is showing one of the big outbreaks, and this was the one in West Africa, in Sierra Leone, Guinea, those countries, back in 2014. And right here, I've listed that there were 29,000 people infected and 11,000 died. And we can say, 29,000 people. That's nothing compared to COVID, but I think Dr. Cody's made this point, and I think that it's a pretty important point to make, that when it's killing off so many people, it stops spreading nearly as easily. Um, it's close to 50% mortality right here, but at the end of the day, that's a lot of people, and that's a lot of people dead. Um, and so, when there's loads of people around you that are dying from this disease with some of the symptoms I'm going to show you here in a second, it is pretty scary, and especially in Western Africa, where the healthcare system isn't what it is here in the United States, and also with the lack of availability of PPE to the general public over there, it makes it that much more difficult to contain the spread. Um, and then also back in 2018 through 2020, there was another 2-year-long outbreak in the Democratic Republic of the Congo. Um, and actually, this epidemic was declared over during the COVID epidemic, back in April, I believe, of 2020. Right at the height of COVID. Um, and the the disease was actually first discovered in 1976 by the Ebola River in the Democratic Republic of the Congo. That's where it gets its name, Ebola. Given the river. Um, so Transmission and symptoms. So transmission initially comes with an infected animal. This could be an infected monkey or fruit bat. And then from there, it's human-to-human contact. And so human-to-human contact and transmission is primarily done through direct contact with blood or bodily fluids of an infected patient. Um, and then also objects that have been coming in contact with bodily fluids of an infected patient. And interestingly, semen from a man recovered from Ebola virus also can be contagious for Ebola virus, but the vaginal fluids from a woman are not. And this is because the virus can stay latent inside of the testes of the male. And then another interesting point is that it can be transmitted from a dead body. And so, there on the first slide, you saw them burying bodies, and this is the reason. The dead bodies can still transmit Ebola, and so therefore they need to bury them in order to make sure that, well, they need to bury them or burn them in order to make sure that there's no more transmission going on. And so here are the symptoms and the aggressive symptoms. So here from day 7 through 9, we have headache, fatigue, fever, muscle soreness. And then, starting on day 10 through 12, you start getting the really aggressive symptoms with, sudden high fever, vomiting blood. And then, moving on to day 11, bruising, brain damage. Then it's where the bleeding from the orifices start, bleeding from the nose, the mouth, the eyes, the anus. And then day 12, this is where you have loss of consciousness, seizures, massive internal bleeding, and death. And right here I have massive hemorrhaging under symptoms right here on the left. And this is because I find this to be the most scary. And that's where my comments about it being scary come from. You're bleeding everywhere, and that is terrifying. think about bleeding out of your eyes. That is scary. And so, if you have people around you that are bleeding from their eyes and their mouth and in all their orifices, it's a pretty scary sight. Um, and so the vaccine. So a brief history about the vaccine. So the vaccine is called a recombinant vesicular stomatitis virus Zaire Ebola vaccine, Ebola virus vaccine. This is the official name. It goes by the name Ervebo on the commercial market. And so I have here that it was approved by the FDA in 2019 for use in the U.S., but before that, it was applied for patent in 2003 to be tested on some animal trials. And so in 2005, a single-dose intramuscular injection of the vaccine was found to induce an immune response in non-human primates. And so it was thought from there that it could be useful for human-to-human spread of the disease. And so back in 2013, during that large Ebola outbreak in West Africa, the WHO ruled that offering people this Ebola vaccine, which at the time was not tried on humans, was actually ethical because of how bad the spread of the disease was. And so the Canadian government, as I have here, it was first developed by the Canadian researchers. The Canadian government donated 500 doses of the vaccine to the WHO to be used in Africa. And so they started using these vaccines. They distributed 500 of these, and this was the phase 1 of the clinical trials. And they distributed them to the healthy individuals in Africa, and were very specific and very concentrated on what the side effects would be. And so they noticed that there was a large replication in the synovial fluid of the joints of the affected people, causing arthritis and some skin reactions. And so the phase 1 clinical trials were stopped after that. And this was because the dosage was too high. And so starting in 2015 again, they started the phase 2 clinical trials, and also a third phase started in Guinea at the same time. And so this is where they started focusing more on frontline health workers, and they lowered the dosage to see if that would have a better effect. And so later in December of 2016, the results from the trials were posted, and it was largely reported that it was 100% effective, which is an incredible feat, and extremely important for fighting this virus over in Africa, and especially fighting it during that really, really difficult time in West Africa where there was a large amount of spread. And then later on in 2019, the FDA approved it for use in the U.S. And luckily we haven't really needed to use it. Well, we haven't had to use it since the 2015 cases here at in the U.S. But since 2019 we haven't had to have any large widespread vaccination against Ebola, which is good. And so it is a live attenuated vaccine, which I will get to here in a second. And like I said, it is a single dose injection, which is nice. You just need to get the one. And then I'll also get to this in a little bit, but it's a genetically engineered to contain a protein from the Zaire Ebola virus. And so the mechanism, and this is where I'll explain the attenuated vaccine. And so firstly, to kind of explain how the infection actually works when infected with the live virus. And so the virus is engulfed by the host cell and then incorporated into the genetic sequence of the host cell, and then it causes dysregulation of the immune system. And so it causes release of pro-inflammatory mediators, so interferons, interleukin 2, 6, 8, 10, and tumor necrosis factor alpha. And because of that, there's a large amount of inflammation and swelling. And as we have learned, with a large amount of inflammation and swelling, there's a lot of vasodilation. And so if there's too much vasodilation, eventually the vascular integrity breaks down, and that's when that leads to that hemorrhaging and a lot of that bleeding. And so in some of those sites where there's a lot of vascular dilation because there's a lot of swelling. Those are some of the sites that we're going to see bleeding from first. And so, to take advantage of the host cell taking up the virus and incorporating it into its genome, the researchers wanted to take advantage of this mechanism in the introduction of the vaccine. And so, the introduction of the attenuated virus into the host elicits a strong cellular and antibody response against the virus, and that's the result of this. And so, as I'll go into here briefly in a second, but it contains a gene for the Ebola virus glycoprotein, produces long-term immunity, and however, the contributions of the innate humoral or cell-mediated immunity is not well understood, and that strong antibody response comes after 14 days. So here on the right, we can see that we have the VSV, the RVSV, the ZBOV, and the ZBOV. And so the ZBOV is the Zaires Ebola virus, and then the VSV is another virus that they use as the vector. And so what the researchers do is they snip out the RNA that codes for the virus's surface glycoprotein, which allows the virus to latch onto the human cells, and then they put that into the VSV, and then they remove a stretch of the RNA that codes for the VSV surface proteins and replace that with the Ebola glycoprotein RNA, and then that's where we get the RVSV ZBOV vector, and then this is what's injected into the patient, and so it actually tricks the immune system into mounting a response against the Zaire Ebola virus, but actually does not cause any sort of infection in the patient. And so, so we get the antibody response, but we don't get the drastic side effects of bleeding and everything like that. There are some side effects, but nothing compared to the actual infection itself. So here we have some side effects of the vaccine. So, actually here on the left, I have a picture of the actual virus itself. It's an interesting looking virus, but some of the effects are, headache, injection site pain. That's kind of to be expected. Some swelling, some redness, some fatigue, some muscle pain, fever, and then, like I said, there was a little bit of arthritis and some rashes, and that's caused by the replication inside the synovial fluid. But a lot of these symptoms are very typical for any sort of vaccine. And for me personally, I would much rather have some of these symptoms rather than bleeding out of my eyes. I can deal with a headache, but bleeding out of my eyes, that is terrifying. So, and then here are my sources, and then I hope to answer any questions you guys have in class, and then I hope that you enjoyed this. Thanks for listening.